All right. So hello everyone. Welcome to this first session of the day. So today's session is going to be about statistical modeling and evaluation, which is like basically task 4 for you. Okay. So as always, I would love to hear from you first. So if anyone can define for me what's statistical modeling, what is statistical model? Just let me hear from you. What do you know? Any volunteers? No one wants to try? Okay, you'll take it that um all right. So okay, let's just get on with okay. I will assume that you don't know what is the definition, but okay. So all right, it's taking some time. You can see my screen, right? Okay, I'm having some connection issues, but do you still hear me well? And do you see the screen, right? Okay, so just let's jump into it. So statistical model is a mathematical model, basically given our set of data. We are making statistical assumptions about how this data was generated. Okay, so what does that mean? It means that supposedly the data we are talking about is like the result of throwing a die or a couple of dice. Okay, so you get numbers, right? So like get 1, 2, and like whatever, and then from that I can like set like state an assumption here and saying that, for example, that the probability of getting any value from 1 to 6 on this dice is 1/6, right? So this is like the simplest kind of probability. I'm putting an assumption that my dice is fair, so every side is equally probable at the other one. So this exactly this saying this distribution or this set of probabilities that I generated the data set, this is a statistical model. I'm saying the distribution looks like this, and I made an assumption, and then basically I'm modeling what the data I have at hand. So it's a mathematical relationship between the variables I have in my data. So there are random variables and non-random variables I can have in my data set. So I'm putting some assumptions about the mathematical relationship between them. So okay, so just to like maybe get into other examples. So okay, I know this maybe like looks a bit intimidating because it's a lot of blah blah blah, But the first example is just saying like in a population, say I'm measuring the height of people in the population, and it's going to going to get like x1 x2 xn is the exact height I'm measured. Like one person is 160 centimeters and the second one is 180 centimeters, whatever. These are the numbers I'm getting. Mathematically, these are random variables, and basically, I can my assumption or my statistical model can be that this distribution is a normal distribution, right? This like what you usually do. A random normal distribution is the one that is like, the bell curve that you define it with mean and standard deviation. So two numbers define it. And basically I can use my data to calculate this, estimate them. Okay, so um, you're basically already done some, or like if you have already gone over the hypothesis testing part of this challenge, or at least you have gone through the tutorial, you already know like part of this. So statistical modeling is a base on what in which like then you can say I can have a hypothesis and test it. You need to have a statistical model first. Okay. Anyway, so this one example. Another example can be that I'm trying to predict, say in my population, I measure the height and the weights of people, and I'm saying like I'm assuming again, because the emphasis on assuming that there is a relationship between the height and weight, and I'm assuming it's a linear relationship, and I write it like this. So it's like y is equal to okay, so y is the weight and x is the height, and these are alpha, beta, and epsilon are just parameters. So this is a linear regression equation. So this is another kind of statistical model. Just as an example, you're not going to be exactly like okay, you have to understand this part. Anyway, why do we need statistical modeling? Basically, it assists in like understanding, like when we're gathering, understanding, and analyzing the data. Um, we will have when have a statistical model, and we have proper understanding of the data and the results we have. And the second part is the one that I just mentioned. Basically, it's like you say, like it helps us to make data driven decisions, allowing us to do like different kinds of statistical inference. Statistical inference that include things like point estimation when we calculate, for example, the mean of like assuming that, because before I said assuming that the high distribution in the population is a bell curve, we can calculate the average of the mean and the standard deviation of that. These are called point estimations. We can also do hypothesis testing, as I mentioned before. We can put basically a particular question and see if the data support them or not, but there is an underlying statistical assumptions there and statistical modeling there. So yes, so basically this is like the goal, basically to have better understanding. Okay, so there are types of statistical models. So statistical models are mathematical models. So they have these mathematical relationships between the different variables. Statistical models are a special kind of mathematical models. So mathematical models can have like you're modeling the reality, like in what you studied physics, I suppose, at some point. So like you have models of you have these equations, physical equations that describe the relationship between different variables, like for example, between the force and the mass and stuff like that. So those were deterministic relationships or deterministic models. Statistical models are not deterministic. So this is what makes them like a special kind of mathematical models. And okay, this is blah, blah, blah I'm saying. Anyway, It is all deterministic because like you can get you have probability, a probability distribution, and the values you get are not completely fixed like with every iteration, right? Because like exactly there are random variables and there are probability here. Anyway, the statistical models can be, there are two types. There are parametric statistical model, like you say when I assume my, I use a statistical model to model the heights with a normal distribution. I can define this normal distribution with two parameters, which are like the mean and the standard deviation. So these are like a finite number of parameters I can use to do this, to determine the distribution. In non-parametric models, there is not like a finite number of parameters I can just calculate to determine like my joint probability distribution. Rather, like I will be calculating them from the data, trying to fit the distribution to the data I have. So I'm not going into these details. Of course, you can look at the references and you can look into more theoretical understanding of this if you want. There are like delving into how to do this in details. Okay, or like more information about this. But I'm just here, it's just like for your information. So there are another kind of categorizing like statistical models. They're thinking about that in your data. Let me, okay. Well, give me a moment. Need to. Right, so I just want to see, to show you. Let's share my style screen. So I would be able to, okay, so I suppose you can see my screen. So just like, so in the data you have, this is like a just sample data I have here, but you have multiple variables in your data, right? So basically you have multiple columns. This is like the multiple variables you have in your data. And you are trying, or depending on what questions you're trying to answer, you'll have, how to say, you are looking for a joint probability distribution for your variables. It can be you are trying to predict some of the, like, for example, in your data, you have like all of these features of like the customers, the cars, like the policy, and then you have one column you're interested in predicting, which is a claim. For example, this is just an example. And you want to predict this in a regression, like you want to use a regression model to basically predict the claim based on these other features. So what you are trying to do here, like just like statistically speaking, what you're trying to find is a conditional model, which is you want to find the conditional probability distribution of the claim based on these other variables. So all the other variables are independent. Your claim is a dependent variable, and you want to predict its distribution based on the others. So this is like what is called a conditional model or a discriminative model. There is another kind of model which we are not going to be concerned with, which is unconditional, where here what you would look for is just that the overall unconditional joint probability distribution for all of your parameters. So it's just like for completeness is mentioned here, so forget about it. We are going to delve. Conditional models can include the several, all of these kind of models, basically. So we're basically getting into like the machine learning algorithm, what machine learning algorithm arise here. So so before this was just theoretical. Now we are getting to the actual algorithm we are going to be using, right? So conditional models can be classification or regression. Um, so basically, you have one column that you want to predict based on the others, right? This column can be, its value can be categorical, basically, it can be, sorry, let's start with regression. So the value can be continuous. It's a number, like the claims. So you just you want to predict this number based on the others, so you assume some kind of relationship. It can be linear, it can be polynomial, it can be you can like, and you can use, and depending, you can use like multiple algorithms to actually do this regression, predict the claim, this continuous value based on the other variables. When your predict like your like target variable is categorical, or like maybe just has two possible values, or like just categories, so it's a classification, different classes. So for example, I don't know in the current data you have, but like when you're trying to classify. So you have, let's say if you want to classify your customers into high risk and low risk, and you already have some data on that, you can basically use a classification model, train it on the training data, and predict the classes on like new data. So basically, yeah, so you understand that the difference between the two. So the regression is the continuous one. When you have categorical and like discrete values, you have a classification model. So they are similar to each other. Depending on the kind of model, this is it's still a statistical model. If you have the relationship between the variables, you understand how it is, or like you have like the statistical assumptions, these are the statistical models. But some of the machine learning models are not exactly, they don't have a set of statistical assumption really when how they work. So these are called predictive models. They are not exactly statistical models, but okay, they do and there are other ways to basically, because the whole goal of statistical modeling is to understand how our data is generated. So you want to understand how, like, you don't want only to predict, you want to understand how this worked, how this relation, what is this relationship between these different variables. So you want to understand the underlying relationships. So machine learning, so we'll get into this in a bit more. There are ways into like what these machine learning models, like the CM trees, random forest, and a neural network, they kind of work in a black box kind of way. So in a complicated way, we don't understand completely how. So I'm not saying it's not that's completely how it works, but we don't understand completely easily the relationships between the variables when we get the predictions from these models. So we need an extra help to when we are using these. But anyway, so these what are called predictive models. So yeah, in and like so like also you can think of this classification also. You can think like of the classification machine learning models between supervised and unsupervised learning, where the predictive uh, value is part of the data, or like it's something new, and your model is just going to come up with it. Okay. Is it everything is clear so far? And questions? I hope. I don't know. I hope it was clear. But are there any questions so far? Okay. So let's move on to the next part. Okay. So just yeah. So this is already something that I already talked about, but like the difference between statistical modeling or like compare side by side. So they are not completely distinct from each other. There are overlapping, but yeah, the statistical modeling is a mathematical formulation, while machine learning algorithms, these are algorithms that like learn from the data without any kind, without needing instruction programming, right? And so statistical modeling is like more concerned with understanding and discovering the correlations and relationship between the variables, while in machine learning algorithms are usually used to just make correct predictions. Um, and and of course, like machine learning algorithms work with large data and can make like better predictions than like the simpler statistical modeling. That was like I was mentioning before. I'm just saying that basically, if we use some of the machine learning algorithms are statistical modeling, and some of them we can still use them in the same for the same like basically goal of understanding the relationship between variables. Well, in a big extent, if we use like work on the interpretation of the model. Okay, so just this is a extra emphasis. So like how to do this. So basically you have like the steps spelled out maybe in the current document, but just and maybe they are not really exactly in order, because some of these steps you need to go over multiple times, and it's an iterative process. But anyway, you can start with already started like it's how the challenge is organized. You started with the data preparation and the data exploration for in the beginning, and maybe you have already done like the univariate exploration of your data with descriptive statistics and also univariate graphs. You can also you have probably also done like the bivariate graphs, so like search for correlations and looked for how like different variables can different relationship between each other. So this is important because you have a feeling of how these variables relate to each other. Some variables are like maybe exactly completely dependent on each other, so this just predict each other completely. Some variables maybe completely unrelated. There is no obvious relationship between them. You can see that in the exploratory data analysis. There are steps in the data preparation where you need to handle missing data and maybe outliers as well. Okay, so there are other steps in the data preparation where like you have to do like or like you might need to do feature engineering. And feature engineering is defined as basically here is that you might need to create or compute new features. So basically, you can like for example, you can compute some like ratio or percentage from the data you already have. to just get a new feature, um, or uh, like also you can choose to ignore some of the features because they are not, you don't think they are relevant. And again, you can do this iteratively. So basically, you can start by working with all of the features and then diffuse them, or like maybe use some of the features at some for some model and some other features in some other model. They depend on like the performance you're getting. Then okay, so there are like important parts that you need to, because you're only going to be handling, actually, because you are using an algorithm, in some cases, you only can handle numerical values. So if you have categorical data, you need to like change them, convert them to numerical values by using like one of like results of several methods you can use. Basically, one hot encoding, lab encoding, and you can find these, of course, in like in scikit-learn or in these libraries you're going to be using, basically. And um, uh, you just need to understand which feature you need to change. You need to convert in that way. When it comes to selecting the statistical model itself, you need to think about what what is the question you're trying to answer. Are you looking to predict a value? Are you looking to answer a particular question? Like, do you have an assumptions you want to confirm or deny? Like, this is coming hypothesis testing, basically. You need also to consider like how many variables you have, like how like which what are the relationship between the variables, independent variables, and the exploratory variables, or the independent variables. So to determine what is the kind of model you want to use, the classification model, the regression model, whatever. It's okay. So basically, I'm just listing. Okay, uh, of course, and after using the statistical model itself, you need to like I don't know, measure, evaluate it, analyze the results, interpret the results you have, and like so, and report basically what you get from that. Again, this can be iterative, and you can go from one step to another multiple times, just to like, depending on what you see. Okay, so going jump right away to the next. So, and here, let me stop and ask you, actually, because I'm expecting you to actually know some of this. So, in evaluating, when you use a machine learning model, say for classification or regression, you need to evaluate the performance of the model, and there are usually multiple ways to evaluate it. So how well it did, how well it's fitting, the quality of it. So say you have a classification, you're using a classification model. What are the metrics, or what are the things that you can calculate or look at to see if your model is good? I want to hear from you some of the metrics, and define them. Okay, I already have this in the Jalan document, but okay. So it's classification model, where you want to, like, you have your model is predicting, for each instance is going to classify it in one of a few classes. It can be binary classes. Let's say it's binary. For example, if you classification model working on emails and predicting whether an email is a spam or not. So this is just a binary classification. in that case, how do you measure if the model works well or not? Any like value that comes to mind, something that you calculate? Um, okay, so in the meantime, just because there's a question in the chat box, so how do we know the right machine learning model for a given data? So first, you what you need to find to like determine is the right kind of model. So of course, like the question you're trying to answer is like determines like if you are like going to be using a classification model, a regression model, or like a predictive model. Um, but then the specific algorithm you're going to be using, this are going to depend on just like you might use multiple. It's not like, for example, a classification model can be, you can use decision tree, you can do classification, you can use logistic regression, and there are multiple algorithms you can use for each neural network. Like all of those you can use for classification. And for regression as well, there are multiple algorithms to do that as well. So you can also, like, maybe you're looking for clustering. So you don't have a particular classes in already determined in your data, but you want to see if you can cluster your data into different groups. See if there are like, if you can I divide my customers in groups that are similar to each other, and then you like run this with like maybe k-mean algorithm or another kind of clustering algorithm and use that. Which one is better? You have to look at again which kind. So like there is usually like a right, there's a right kind. Of course, if the question is classification, you cannot use regression for that. But which particular algorithm you use, you can use multiple and see which one works better for you. You can try multiple usually. And also there are like models that have hyperparameters that you can fix. You can choose by yourself. So not everything is like when you do the training, there are also hyperparameter you can fix, and these basically you can also choose. And in cross evaluation, you can fix this hyperparameter if you need to. So I hope I answered the question. Did I, Abraham? Um, okay, great. So because there's not enough time, let's just go on. So yeah, so for each kind of machine learning model you're going to use, you have to, like, there are different metrics you can look at for evaluating it. So just for example, for classification, there are like can look at like when you, if you use again scikit-learn to do this, you can just look at the classification report, or it's called the classification summary, and basically see the value of each of those. So but you just need to understand what does it mean. So the accuracy is very clear, like of course you are like you are dividing your data into training and in test, right? And you train your model on the training set, and then you test it on test sets, and then you calculate these values on the test set. And so the accuracy is like how much how much of the predictions are correct in percentage. As a precision is uh, like how many like of the like how many of the like predicted like for a particular class or predicted how many of these. Let me just use an example so make it clear. Let's say that go back to the classification of spam emails. So if my model, I'm using my model to predict the spam emails in like, so only it is a binary classification, only spam or not spam. So among the model output that they said these are spam, how much of them are actually spam? So this is a precision. The recall is in this case is like how much of the actual spam emails my model was able to capture. So like did it capture all of them, or like did it fail to capture like some of them? So this is what the recall calculate for you. And the F-score is a measure that is calculated from both precision and recall. And just using the example of spam and non-spam, it's sometimes if I look at, well, why don't I just look at the accuracy and just be done with it? Why do I need all of this? It depends on the case. For example, in the spam, particular this example of spam emails, because the number of spam emails is usually small compared to the others. Oh, I don't depend, but anyway, let's say that's true. If like I can have a model that can have like, let's say I have in 100 in my training set, I have 100 emails, there are only 5 spam emails in those, right? So if I just use a classification model that is very lazy, is just going to say every email it sees is not spam, it's going to get automatically it's going to get 95% accuracy, which is very high. And if I just look at that, I'm going to say like, oh, this works very well, I'm fine. But the recall of this model, because it didn't capture any of the spams, it have a recall of 0, which is very bad. So I can see, looking at the recall and the accuracy at the same time, I can know that this model is not very good. So just an example. So that's why you just need multiple metrics sometimes. For regression, there are other, of course, there are mean absolute error or root mean square error. These are calculated differently from like the predicted value, the difference between the predicted value and the actual value. And yeah, so in evaluation, so these are for the supervised learning, right? Because I have an actual value, I have the ground truth, I can compare my predicted value with the ground truth, right? In my test, data set. But in the unsupervised learning, which in some, for example, clustering, in clustering, I don't have a ground truth. I'm like, I don't know, but there are other measures for evaluating the performance of clustering model. So in a clustering model, you have to calculate things like how close are close are clusters together, how separate they are from each other, different clusters, and these are different metrics that can calculate this. The calculations for some of metrics are just differ from each other slightly on how they are calculated. So like you can measure several, and like you can look up like which what each metric shows you basically, so you can understand like each one of the metrics, like it's measuring particular performance, particular aspect of performance for your model. So you just need to understand what it is actually doing. Yeah, so um, let's just move on to the next part, the interpretation. As I said before, some for machine learning models work somewhat of like a black box. So they can make the correct predictions, but we don't exactly understand how they arrived at those predictions exactly. So starting from particular the features they have, how did they predict this output, right? What is how important was each value, how variable, for example. And basically, there are tools or methods that can help with this. So basically, the two tools mentioned here, they just tell you like how more or less um, the importance of each independent variable or the importance of each variable in the input to the output. And basically it gives you some understanding of like how the model work basically. So it's just based on for uh I'm not sure if it's pronounced sharp, but anyway, it works on it's based on some game theory. And basically it works, it's model agnostic, so it works with like all kind of machine learning models basically. And what you need to do is just install this library and use it with your model to see how like the different variables are contributing to the output, giving you some understanding basically. So just like maybe yeah, just to I don't know that because it's not enough time, but okay, so just to show this, okay. Um, so you can just find like maybe I'll not sure if I added this as a resource there, but like basically say I have some data here. Um, it's like a telecommunication data, and the problem I'm like it's not necessarily like to go through like exactly what it is the question I'm trying to answer, but it's a classification problem. And so in this beside I'm just importing this library, and basically what I need to do is like my let's put learn here, have a my classification trend test split. I train my I'm using random forest classifier here after training it, and like this is just like the part of I'm training and running the testing my model, right? And I got these variables for these different metrics. Um, um, so here to use this, I just need to run the explainer on my model, and basically okay, so just like I maybe run it here. Okay, I think I can see it here. Can see a, a graph like this one that will show you, basically it will show you the output of this library is going to show you like a weight of importance for each variable you have. So like so you have like the magnitude down here, and then these are like in order of importance. So the status is the most important one, and then like going down. These are like divided by classes because it's classification. I have two classes, and like it's showing you for how much for each class. So it can be different, right? What predict each class can be different. What else? It's this predicted well, this value it returns. These weights are additive, and they what to say, if for missing or irrelevant, it just basically it corresponds to the importance of all the variables. So if the variable is not important at all, you'll find the value is zero, and so on. So I suppose it's very clear how it works. You can just look up how, like you can find the, maybe I think the resource to just the documentation, you can look at it, or maybe the different resources to how to use it, how to understand the interpretation there. So yeah, let's say like that's concludes this. So any questions? Anything that is not clear? Um, okay, so there's a question here about how to interpret the graph. Okay, so there are multiple graphs that you can get basically, and you can look at the documentation. I'm so sorry, I was talking without it closed my, I muted myself. Sorry. I was talking and muting myself. What I was saying is that basically the number you get from this SHAP basically is correspond to the importance. The higher the number, the more important the variable is for the prediction. Meaning, let's say like in the data you have, you are trying to predict the claims, say in this is the target variable for you, and you run a regression model using like a bunch of your variables or all of them, and to predict this claim, and then like you get say a good performance, and then you run this like explainer from SHAP. You get some like you can order like all of your variables. The ones that are the highest, they have the highest values. These are the most important. Some of the variables you will find that they have really small um, value from this, and that means that they are not really important. They don't affect the claim. Let's say, for example, you find that the gender doesn't have any effect on the claim. So that means that it's really it's not predictive. It doesn't have any predictive power for on your claim. So you can. I mean, I hope it's clear this way what it means. Is it? Does it answer your question? Yeah, I wasn't sharing anything. I was just saying blah blah blah. Okay, so I just wanted to share sorry, the resource about this. But I'm not sure if it's in the current document or not. Yeah. There's a question? It's Gaia.
Yes, hello.
Hello. Go ahead.
Yeah. I have some questions. One question.
Okay. Go ahead.
How do we decide beyond using different evaluation metrics such as RMSE versus MA statement? Absolute error for regression tasks or precision versus F1 score for classification tasks, especially when one metric suggests a good performance while another indicates a poor result.
Okay, so well, you need to understand what each metric is. So, like for regression, for example, I think these different metrics are more or less measuring the same thing. Well, they are different, slightly different calculations, but they are how to say, they are very close to each other. But for classification, there is the difference between accuracy and recall is important in some cases. So you just need to understand what is recall and what is accuracy. So as I said before, recall can, if you have a very low recall, it means that maybe your model is missing some particular. The recall is measured for a particular class, so the model is missing this particular class, is not getting it, is not predicting it. While the accuracy, maybe because it has a small number, the accuracy is still high because the class itself is not very well represented in the data set. So you just need to understand what each metric is measuring and calculate multiple of them and see if you're getting a good performance on them. So yeah, I'm not sure if I answered the question. Did I? Does this answer the question?
Yeah.
Okay, good. Anything else? Any other question? Okay. If there are no other questions, I think we can end the session here. As always, if you have other questions, you can tag me on Slack or yeah, that's all. Thank you everyone for being here.